There's a sort of pattern to these things. So for assurances, instead of just dealing with payable at the end of the year, we have to deal with payable immediately or payable with a bit of a delay. The equivalent situation for annuities, where we're not really, it's not a matter of there being a delay or something, but it's a matter of they're being paid more frequently. And also we've got to look at, as well as annuity due, we've got to look at annuity immediate as well. Okay, so that's what this topic is here, so we'll look at that now. So let's remind ourselves what the annuity is. So A double dot X equals 1 plus PXV plus 2PXV squared plus 3PXV cubed, and that, as you can see, for the fact there is no discount there, is payable at the start of the year. Okay, now we have a new piece of notation here which has no double dots on it. Okay, this one is annuity due, and this one is called annuity immediate, which is a bit weird because you wait to the end of the year, but it's immediately at the end of the year of the benefit. Okay, well, if you're getting it just at the end of the year, you don't get this first one, but what's the chance you get the first benefit? Well, the first benefit is the end of the year, so the chance you get that is px, the value of it is v. The chance you get a second benefit is 2px times v squared for the value. So the relationship between ax immediate and ax due is very, very simple. Ax due is equal to ax immediate plus 1. Okay, so that's the first thing we need to think about. If we just want the value of the immediate annuity, we just take 1 off the due annuity. Supposing the annuity is paid continuously throughout the year. Okay, this is continuous. Well, in this case, it's a bit like adjusting by the half a year of discounting for the assurance. We basically just say, look, we're going to treat that as the average of payable at the start of the year and payable at the end of the year. Okay, so that is annuity due plus annuity immediate over 2, which, with a fairly simple piece of maths, you can see is a double dot x minus a half. Okay, now we have a slightly more complicated issue, that if it's payable more frequently, if the annuity is payable more frequently. Okay, so another piece of notation, AX2. That means it's payable toothly, so half the benefit is payable twice a year. So strictly speaking, what this is a half plus a half pxv to the half plus, and a half times that, in fact, plus a half times pxv plus a half times 1.5 pxv to the 1.5, etc. But we don't have the LXs part way through the year, so this is sort of really not a good way of doing the calculation, although that, strictly speaking, is what it is. Okay, but what we say is, or what we have to think is go back to looking at the cash flows and think, what would annuity due be and what would annuity immediate be? Okay, so and really what we have if you think about sort of breaking it down a bit, is this plus this plus whatever would the next one be is half of A annuity due X. Okay, so that bit is a half of A double dot X. Okay, then we've also got this bit, which is payable halfway through the year, this bit, which is payable after 1.5 years. Well, that is the average, effectively, of annuity due and annuity immediate. Okay, payable halfway through the year, so annuity immediate is payable at the end of the year, annuity due is payable at the start of the year. So this thing, which is payable halfway through the year, halfway through the next year, is basically going to be the average of the two. Okay, so that is going to be a half of the average of annuity due X and annuity immediate X. Okay, so put that together, we've got A double dot 2 X is equal to a quarter of A double dot X plus a half A double dot X plus a quarter of AX. Okay, so equals 3/4 of A double dot X plus 1/4 of AX, which is A double dot X minus 1. Okay, so the whole thing, we've got a whole A double dot X minus a quarter. Okay. Now, if you're wondering where this is going, okay, remember the thing on the mind map is m minus 1 over 2m. Well, the m is 2, so it's 2 minus 1, which is 1 over 2m, which is 4. Okay, and that's what that a quarter is. Okay, so that quarter is that. But that's not really sufficient to justify it, so let's actually do it for mthly here. So A double dot mx equals 1 over m, okay, times times 1 because it's going to be paid at the very, plus 1 over m times discount period 1 over m times 1 over m px plus 1 over m v to the 2 over m times 1 over m px plus 1 over m v to the 2 over m, so the 3 over m times, so that should be 2 over m there, times 3 over m px. Okay, so this thing after m terms, okay, we're going to get a 1 over m v to the m over m times m over m px, okay, which is 1 over m v times 1 px, which is the second term of a annuity due x. Okay, so what we've got is 1 over m times ax. We've also then got, so that term is coming from there and there. Then this term is 1/mth of the way from annuity due to annuity immediate. Okay. So we have to add 1/mth of the way from annuity due to annuity immediate, which is m minus 1 over m times annuity due plus 1 over m times annuity immediate. Then the next term is 2/mths of the way from annuity due to annuity immediate, so that is m minus 2 over m times annuity due plus 2 over m times annuity immediate, plus, and we go all the way up to 1 over m annuity due plus m minus 1 over m annuity immediate, and that's it. Okay, so that whole thing is equal to 1 over m, and now it's just about arranging terms. A double dot x into 1 plus m minus 1 over m plus m minus 2 over m plus plus 1 over m plus ax, and our first ax is m minus 1 over m plus, sorry, got that the wrong way round, just to keep it clear. So ax, we've got 1 over m, 2 over m, etc. 1 over m plus 2 over m plus plus m minus 1 over m. And now it's really just a matter of working out what this whole summation is. Okay, well, I could replace the ax there with the annuity immediate with the annuity due minus 1, but I'm still going to have to sum this whole sort of expression. So let's just do that. 1 over m a double dot x into 1 plus 1 over m, and then what? Then that is going to be, the sum of all those is going to be, there are m minus 1 terms times by the average of those terms is m over 2, because it's 1 plus m minus 1 over 2, plus ax. Well, the sum here is from 1 over m to m minus 1, so 1 over m to m minus 1 there, so we just don't have that 1 in there, so we have 1 over m into m minus 1 times m over 2. It looks complicated, this, but actually it's just rearranging a bit of stuff. It's not too hard. So let's just get a different coloured pen and start crossing out some stuff. So that 1 over m goes with that m, that 1 over m goes with that m, and we're going to have 1 over m, open brackets, a double dot x into 1 plus m minus 1 over 2 plus ax into m minus 1 over 2 equals 1 over m a double dot x into m plus 1 over 2, because that's going to add 2 to the top there, plus a double dot x, so ax is a double dot x minus 1 into m minus 1 over 2. Just need to push that a little bit further. So equals 1 over m a double dot x into m plus 1 over 2 plus m minus 1 over 2, which is just m minus m minus 1 over 2. Which is m and m cancel there, a double dot x, and you've then got minus m minus 1 over 2m. Okay, and that, so if it's monthly, if you've got an annuity that's payable monthly, instead of just looking up the annuity calculator, you just take off the m minus 1 over 2, and there's a huge amount of algebra there. Yes, it is quite a lot. You can't get away from the fact it's quite a lot of algebra. Okay, but you've only really, I mean, you might just have to do it on the exam. It's fairly unlikely, but all you've really got to do is just remember that formula, and that is how we adjust for a whole of life annuity. We have to be careful if it's a temporary annuity. So just remember, substitute this in when it's a substitute this in for the whole of life annuity when it's a temporary annuity. So let's just demonstrate that. Okay, so let's calculate what a double dot 12thly is. Okay, let's calculate that. Well, first of all, let's do this, which we did in the last lecture. So that's a double dot 40 minus v to the 20, 20p 40 v to the 60. Sorry. A to the 60. And then, so we want a double dot 12thly 40 20. We've just got to replace each a double dot whole of life with this adjustment. Okay, so it's a double dot 40 minus 11 over 24. Okay, minus v to the 20, 20p 40, a double dot 60 minus 11 over 24, but that is substituted there. So this minus 11 over 24 gets multiplied by this. You sometimes see it written out with the minus 1124 taken outside here into a factor of 1 minus 20p 40 v to the 20. That's just not a good way of, I mean, that is true, it's correct, it's algebraically correct, but it's not a helpful way of thinking about it, really. because it's easiest just to think you are just doing that substitution on the whole of life annuity. Okay, and then everything else just comes out in the wash. So you don't learn this formula. Okay, you don't really learn that formula. You learn that formula. To make it a bit thicker, just to illustrate the fact you learn that formula. Okay, and that's your standard formula from the previous lecture. And this is the standard thing where we take the whole of life and take off the end that we're stopping by only going for 20 years and discount by the 20 years. That's how to think of that. So it's a 40-year annuity. It's an age 40 annuity minus an age 60 annuity, but the age 60 annuity has to be pushed back 20 years into the future. That's how to think of that. And this adjustment is an extension of taking a half off because it's halfway through the year, so it's the average of an annuity due and an annuity immediate. Okay, so that is the m-1 over 2m formula.